Hello everyone, welcome back to my channel. In this video, we will be discussing about the solutions of our first internal test of data science. So let's get started. The first question is, how are unstructured data analyzed, and give the example of data mining activity to analyze unstructured text data. So, unstructured data refers to the data that does not have any predefined format or structure, such as text, images, videos, audios, or social media posts. Analyzing unstructured data involves extracting meaningful insights using advanced data mining and text processing techniques. The steps that are involved in unstructured data are data collection. In this step, we gather unstructured data from various sources like emails, social media, and documents. The second step is data preprocessing. In this step, we convert the unstructured data into a machine readable format. Text data clean using tokenization, stop word removal, and stemming laminization. Image data process using computer vision techniques like object detection, and audio data using speech to text conversion. Feature extraction. In this step, we extract features or patterns from the data. Text features are extracted as frequency inverse document, whereas visual features are extracted as color histograms and shapes and pixel intensities. Now, the fourth step involves model building. In this step, we apply machine learning or deep learning models to identify patterns, classify data, or make predictions. The next step involves model building. In this step, we apply machine learning or deep learning models to identify patterns, classify data, or make predictions. In the last step, we do data visualization. In this step, we represent insights visually using dashboards or graphs for better interpretation. Another example of data mining activity is extract insight from thousands of customer reviews to classify feedback as positive, negative, or neutral. First, we do pre-processing in which we remove noise like emojis and hashtags, and in second step, we tokenize and laminize our text. The next step is sentiment analysis, in which we use a pre-trained model or supervised machine learning techniques or naive Bayes to classify feedback. The third step is clustering, which is an optional step in which we use clustering algorithm like k-mean to group feedback by themes like product quality and delivery issues. The last step is generating an output. In this step, we visualize complaints. Uh, for example, delivery delay is a top issue occurring in 30% of negative feedback. Now, let us discuss about the next question, that is how text mining techniques can automate the process of classifying written complaints. So, the text mining techniques enable the analysis and classification of large volume of written complaints by converting unstructured data text into structured data. These techniques automate the identification of complaint categories, saving time and improving accuracy in resolving issues. Steps to automate complaints classification involves first is data preprocessing, data cleaning, remove noise such as special character numbers and irrelevant symbols. For example, converting theft of my phone on 2023 to 20 at MG Road to theft phone MG Road. Tokenization, breaking down into words or phrases. Example, theft phone MG Road and road. All these words are separated. Now, in next step, we have to remove the stop words like, for example, theft and phone. Now, stemming and lamination is the second and the last step in data preprocessing, in which we reduce words to their root forms. For example, stolen to steal. The next step is feature extraction. Extract meaningful patterns or representations from the text for analysis. TF and IDF, term frequency inverse document frequency, assigns importance to words based on their occurrence in the text. Bag of words represent text as a set of word count. And word embedding captures semantic meaning by representing word in vector space. Classification algorithms use machine learning or deep learning models to classify complaints into predefined categories. Machine learning approaches, naive-Bayes classifier, is ideal for text classification based on word probabilities. Support vector machine (SVM) separates complaints into categories using word features. Decision tree is used for multi-class classification problem. And in deep learning approaches involves recurrent neural networks (RNN), which is suitable for sequential text data. Automating the process. Pipeline for automation. Input complaint text. Pre-process, clean and extract features, classify, use trained models to assign categories. Now the output now the output is mapped categories, that is theft to IPC section 378. Feedback mechanism also comes under automating the process, in which we continuously improve the model by training it with new complaints and feedbacks. Now, let us begin with the solution of question 3, which says that consider the following complaint. Suggest the approach, algorithm, process to identify applicable IPC BNS section to recommend applicable BNS or IPC sections. So, this is the given complaint for which we have to suggest the approaches, algorithm, and processes that are applicable for the same. Let us understand the problem. The goal is to analyze a written complaint using text mining and NLP techniques to classify it into applicable IPC or BNS sections. The given text is unstructured data and requires processing to extract meaningful information and categorize it effectively. The first step involves text preprocessing. Before applying algorithm, the complaint text must be cleaned and prepared. Tokenization split the text into words or sentences for analysis. For example, theft of my phone by an unknown person is converted into tokens like theft of my phone. Each of the words are separated. In clean sentences, we remove the words like the, was, at, which do not add any value to our text. Now, stemming and laminization. Reduce words to their base form to avoid duplication. Named entity recognition NER. NER extract key entities such as place, date, object, physical description. Using NER tools like Spacy or NLTK, we can identify these entities and structure them for analysis. Another step is feature extraction. To classify the complaint, extract feature that indicates its nature. Keywords theft, mobile phone, and black jacket. Bigram or trigram analysis. Analyze word pairs or triplets for text. For example, mobile phone text. For example, mobile phone theft. TF and IDF assign importance to the words based on their frequency in the text. Fourth step is classification algorithm. Algorithms to identify the applicable IPC or BNS section include name-based classifier, a probabilistic algorithm based on word frequencies, which is useful for text classification problems that support vector machine and separate the text into classes based on features. And another one is rule based matching. Directly matching keywords like theft to IPC section 378 using predefined rules. Deep learning models is optional and use transformer for advanced semantic understanding. Mapping to IPC and BNS. Based on the analysis, the crime is identified as theft. Match the keywords with IPC and BNS. IPC section 378 theft covers movable property stolen from an individual. BNS broad category is crime against property. Now the sixth step is tools and libraries. We can implement the solution using programming languages, Python or R, libraries tools, NLTK, and specify text processing, tokenization, and NER. Fourth question is suggest suitable data structure and algorithm for question 3. So the following are the some applicable data structure for the algorithm. Suitable data structure are first text if the data is text data, first data or input, organization of data and possible operations. The second is text data, string arrays or lists for tokenized data, hash tables or dictionaries for word frequencies. Knowledge graph, the graph databases for storing IPC BNS sections and relationships, hash tables or dictionaries can be used. Now, for NER, list or arrays are used for storing the extracted entities, and hash table and dictionaries for entity frequencies. Now, for storing part of speech, we use list or arrays for storing part of speech tags, hash table or dictionary for part of speech tag frequencies. Data structure involves dependency parsing, graph data structure for storing sentence dependencies, hash table or dictionaries for storing dependency relationships. For IPC section identification, we use hash tables or dictionaries for mapping keywords to IPC BNS section lists or arrays for storing identified IPC BNS sections. For ranking and filtering, we use priority queues or heaps. And additional data structure are also used like trie or prefix tree for efficient text matching, suffix tree for efficient substring matching, and graph neural network for learning relationship based on IPC and BNS sections. Now, the last question is explain suitable matrices to access the performance of algorithm in text mining. The matrices for evaluating text mining algorithm. When evaluating text mining algorithm, it is essential to use appropriate matrices to measure their performance in terms of accuracy, reliability, and efficiency. The choice of matrices depends on the specific tasks such as classification, clustering, or sentiment analysis. Key matrices that are used for text mining involves accuracy. It measures the overall correctness of the prediction. The formula involves number of correct prediction upon the number of total predictions. For example, if 90 out of 100 complaints are classified correctly, accuracy will be 90%. In precision, the precision measures the proportion of correctly identified positive instances. The formula is given below and it is used in scenarios where false positive are costly, such as fraud detection. The third matrix is recall or sensitivity matrix. It measures the ability to identify all relevant positive instances. The formula is given as this and it is used in critical in scenarios like crime detection where missing a release is unacceptable. The, the last matrix that we can use for IPC and BNS section is F1 score, the harmonic mean of precision and recall, balancing the two matrices. Formula for F1 score is equals to 2 into precision into recall upon precision plus recall, and it is used in imbalanced data set where one class dominates. Thank you for watching this video. Do like, share and subscribe.